Pre-calculus, time for hyperbolas, day 2. So let's talk about some definitions and some vocabulary. A hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances from 2 points called the foci is constant. In an ellipse, it was the sum of the distances that was always the same. But in a hyperbola, it's the difference. As a hyperbola recedes from its center, so for instance, here's a hyperbola, sort of, as it gets farther out from the center, the branches approach lines called asymptotes, just like the asymptotes we saw in rational equations. So we get closer and closer to these asymptotes. All right, now, really important vocab. The transverse axis. The transverse axis is a line segment whose endpoints are the vertices of the hyperbola. So if your hyperbola opens horizontally, your transverse axis is horizontal. If it opens vertically, your transverse axis is vertical. It's just the one that goes from one vertex to another. The conjugate axis is basically when you're making the box. The conjugate axis is the other sides of the box that aren't the vertices. So here was our transverse axis. The conjugate axis is the one that never touches the hyperbola. So this one is the conjugate axis. The conjugate axis is a segment of length 2b units that is perpendicular to the transverse axis at the center. So the transverse is the one that goes from vertex to vertex. It touches the hyperbola. The conjugate is perpendicular to that, and it never touches the hyperbola at all, and it also doesn't touch the foci. So you will need to remember these words. I don't ask you to memorize a lot of stuff, but transverse and conjugate axis are important things to know. Basically, if I say transverse axis, that means the main axis. If I say the conjugate axis is vertical, that means the hyperbola opens horizontally because the transverse is horizontal. Finding foci. So in an ellipse, the foci are inside, right? So the distance from the center to one focus, which is C, is always shorter than the distance from the center to the outside, which is A. But in a hyperbola, the foci are sort of on the outside. They're farther away. So the distance from the center to one focus, C, is actually longer than the distance to the vertex. So instead of subtracting, to find C in hyperbolas, now C is actually going to be the hypotenuse. So C squared equals A squared plus B squared. And we'll do some practice with that. But that's the equation that you use for hyperbolas. Equations of the asymptotes. So when you make your box and then you draw the lines through the corners for the asymptotes, you can write the equations of the lines the normal way. Find the slope, find the y-intercept, and write it. But there is sort of a shortcut. So the slopes of the asymptotes are always plus and minus rise over run. One has positive slope, one has negative. They're just the opposite of each other. And you're basically doing the rise over the run of the box. Sometimes that's A over B, sometimes it's B over A, depending on the hyperbolas, but it's always rise over run. And you can use the center point and the slope to write the equations in point-slope form. So here are your general form equations. Y minus k squared. This would be a horizontal hyperbola, right? The equation would be y minus k, and you can use this, because we know the asymptotes go through the center, so we can use the center, equals plus or minus rise over run. In this case, it would be b over a, because this would give you the rise and this would give you the run, times x minus h from right here. A vertical hyperbola instead to get the equation of the asymptotes. There, you would still do y equals k, you would still do plus or minus, you would still do x minus h. In this case, since the y is first, it would be a over b. But there's no need to have to hassle about memorizing that. Just, you're doing rise over run, so that's always going to be the one under the y over the one under the x. And that's how you find the equation. All right. I'm going to do number 4 first, because that I found that doing the ones with the pictures, it actually makes it a little harder. So we'll just do one of these where it describes it and talk about how you can find the equation. So I do think it's useful to sketch a quick graph. Vertices at 0, 7 and 0, negative 7. Okay, these are right above each other, so I know that this is going to be a vertical hyperbola. They couldn't open sideways. That wouldn't make any sense, right? What's going to go like that? It's got to be vertical. So that tells me that my y term will be first. And I can set some stuff up. This also tells me where the center point is. The center point is always halfway between the vertices. So in this case, my center point would be 0, 0. That means this is y minus 0 squared, x minus 0 squared. And since this distance from the center to the center to the vertex is a, I can fill that in too. From the center to one vertex is 7. So I'm going to put the 49 there. Okay, that's all the information we can get out of this first part, but now we've got this conjugate axis of length 18 units. The conjugate axis is, remember, the one that doesn't touch the vertices. So over here, this is 18 units long. Remember that the conjugate axis is length 2b, because this is giving you basically from one side of the box to the other. But b is just the distance from the center to one side of the box. So b is 9. And that means that number is 81. That's it, you've written the equation. Sometimes, however, they make you work a little harder to figure out what b is. So I'm going to skip down to number 7 and work on that one. I will then pause, well, no, I will ask you to pause the video and try some of the other ones, and then I'll give you all the answers so that you can compare it. The homework for tonight is it's entirely about this stuff. So I'm focusing on that. Number 7, vertices are at 1, 1 and 1, negative 3. Okay, once again, that tells me this is vertical. That also gives me the midpoint, halfway between 1, 1 and 1, negative 3 is 1, negative 1. Right? You can just take the average. 1 plus negative 3 is negative 2, divided by 2 is negative 1. So the center is at 1, negative 1. So this will be y plus 1 squared, because the y value is y coordinate is negative 1, and this will be x minus 1 squared. The distance from the center to one of these vertices is 2, so I can fill this in. A is 2, so a squared is 4. Now I'm going to need to find b squared. It doesn't give me b, and it doesn't tell me anything about the conjugate axis, but it does tell me something about the foci. The foci are at 1, negative 1 plus or minus square root of 5. The 1, negative 1 is exactly the same as the center. So all this means is starting from the center, to get to the foci, you go up square root of 5. So you would go up to make one of the dots, and then down square root of 5 to make another focus. So that means the distance from the center to one focus is just this square root of 5. So c is the square root of 5, which means c squared is 5. The equation we're using is c squared is a squared plus b squared. So 5 equals, there's my a squared, 4 plus b squared is 1, and that's what we want there is b squared. So that's the equation. So if they give you information about the foci, you figure out the distance from the center to one focus, that's c, and then you use c squared equals a squared plus b squared, excuse me. That's the basics. The rest of it is just practice on those concepts. The homework for this little section is page 651, 31 to 36. So it's only 6 problems, and they're like this. It can be very useful to sketch a graph. It's not required, but I find it pretty helpful to help me figure out what's going on. For number 36, you need to know something that we don't, it's not part of our lessons, it's just a little detail. Eccentricity is c over a. That is the ratio of the distance from the center to one focus to the distance from the center to one vertex. In an ellipse, that's always less than 1. In a hyperbola, it's always greater than 1. But the bigger this number, the longer and skinnier your ellipse or hyperbola is. Just an interesting thing. Anyway, they give you the eccentricity in number 36, and they expect you to use this piece of information to figure out whatever's missing. So there you go. All right, pause, please. Try some more problems. You can come back and check the answers in a moment. Okay, I hope you've tried some of the other problems. This is obviously a different sheet of paper, but it already had all the right answers on it. So, the answer to number 1, y squared over 9 minus x squared over 36 equals 1. This is how I found it. I knew what the focal length was, so I could find c squared and I could find a squared, and then I just used the formula to figure out what b squared was and plugged it in. For this one, same deal. I was misled at first because the focus is something 2 plus square root of 34, but that 2 actually comes from the center point being at -3, 2. So the 2 isn't actually part of the focal length. The focal length, or c, is just square root of 34. c squared is 34, a squared is 9. Do the math. So y minus 2 squared over 9 minus x plus 3 squared over 25 equals 1. For number 3, all you need to do, because they give you the asymptotes, continue a vertical line through the vertex until it hits the asymptote. And do the same thing on the other side, and that gives you the box, which means a is 2 and b is 4. So the equation is x minus 1 squared over 4 minus y plus 2 squared over 16 equals 1. All right, we already did 4 and 7. Number 5, the conjugate axis is 6 units. Conjugate axis is, it gives you b, so that's where I got 3 and then squared it to get 9. The equation is y plus 5 squared over 16 minus x minus 1 squared over 9 equals 1. Number 6, x squared over 25 minus y squared over 1 equals 1. You don't really have to put the over 1, but we normally do. And we had already done number 7. Number 1 here, you have to group, factor. Remember that you have, when you factor out the negative, that always changes the sign of one of the terms. 24 divided by -4 is -6. And then remember that you're adding, I should have written this a different way. When you complete the square here, you have to add a 4. When you complete the square here, you have to add a 9, but you've got to remember that -4 outside, so you're actually doing -4 times 9. And then finally divide by 4. So x minus 2 squared over 4 minus y minus 3 squared over 1 equals 1. Center is at 2, 3. Vertices 0, 3, and 4, 3. And foci 2 plus or minus the square root of 5, 3. Equations of the asymptotes, y minus 3 equals plus or minus, rise is 1, run is 2, 1/2 x minus 2. For number 2, your equation is y squared over 16 minus x minus 1 squared over 4 equals 1. Center at 1, 0, vertices 1, negative 4, and 1, 4. The foci are at 1, and then positive and negative 2 square root of 5, or if you like, 0 plus or minus 2 square root of 5. All right, and then for the equation y equals plus or minus, rise is 4, run is 2, so that reduces to 2, slope of 2 times x minus 1. Writing the equation from the graph, we already practiced some of this. Opens horizontally, x minus 1 squared over 4 minus y plus 2 squared over 9. Sorry for the beeps. Number 4, x minus 1 squared over 1 minus y minus 3 squared over 4 equals 1. And number 5, length of the transverse axis is 8 units, which tells me that A is 4. Foci are at 6, 0, and negative 4, 0, which tells me that C is 5, and that the center is at 1, 0. I used the formula c squared equals a squared plus b squared. Figured out b squared was 9. Didn't actually even need to figure out what b was. X minus 1 squared over 16 minus y squared over 9 equals 1. Sorry for my messy handwriting. Okay, that is it.